And also you have the issue of global production network. A different term for this is global value chain. Any contemporary corporations, any contemporary business, especially those very large businesses, can be uh, divided into many sub-processes. You have a corporate headquarters, you have a corporate research and development department, you also have a design department, procurement, marketing, production, testing, and logistics, post-sale services. So one big corporation can be divided into many departments, and they all have their own job to do. And at the different locations across the world, you know, different locations may be really good for any of these particular components. For example, for research and development, maybe some cities have a big research institute, big universities. That would be very good for the research and development. For places where you have cheap labor or some necessary resources, the production should be there. And in locations where you have a lot of other industries, and you can really get a lot of market information to project how the market will change. And for any other research, any cities with particular kind of industrial mix, the testing the product will maybe a good place to be. So this, you could have a many different locations that fit niche of a different department from the same corporation. Therefore, one corporation can have facilities in a number of different countries. So depending upon what specific advantage can be offered by those locations for the corporation's research and development department, design department, key component, general parts, and the final assembly. So that's really not just a specific, not just one or two specific locations. It's a series of a set of all different locations that make the company work well. So we are not just talking about made in particular country. We are talking about made in the world. That because that cooperation production involved productions and services from numerous locations across the globe. So that's the concept of global production network, a global value chain. Okay. So now I have one example here. The production of a Barbie doll by Mattel. You can really see some parts from Taiwan, Japan, some parts from Indonesia, Malaysia, some parts from Japan, some from the U.S., and some from China. Eventually, market come back to the U.S. So that really gave you a sense of made in the world concept. Yeah. And there's some other factors such as government intervention. Sometimes government feels the need that they want to retain some critical industries within within the country. So even if some industry is losing money, they try to subsidize those industries, and that's because of the political considerations. Okay. Uh, Also, there are some historical reasons, inertia. Some industries started out from place would be very expensive to relocate. Therefore, the industry will always be there. Okay. So here you can see at the bottom of this slide, you can really see some cost of regulatory compliances for U.S. manufacturing. This, U.S. government have regulations on labor, on environment, on also on many other issues. Those regulations, a lot of times translate into some business costs. In this context, we can really see that the regulatory costs could be on average about 10 to 11% of the total cost of business. And to many corporations, especially for small corporations, that may be a big part of the cost. they can ill afford to pay this part of the cost. So government do play a role in shaping the decision of corporations regarding where they are going to locate. Also, you have so-called food loose industry. These are the industries that are not affected by a major location factor. Computer chips. And computer chips, basically, you can make computer chips almost everywhere as long as you have some nice dry weather. Jewelry making, you can make jewelries in almost everywhere. In big cities, small cities, people's home or factory, almost everywhere. So there's no any obstacles to locate the jewelry industry in anywhere. Okay. So this is a map that shows the location of steel industries during the early days, 1980s. During that time, you can really get a sense of a major steel makers which country. You have the United States, you have Japan, you have the USSR, also other developed countries. And developing countries only very small slice of steel industry in 1980s. Now, come to 2014, the situation is opposite. Then most of the steels are made by developing countries, and steel made by developed countries only a very small slice, about a quarter. And China has become the largest steel makers of the world today. Okay. Finally, I'd like to talk about the Weber's industrial location theory. Similar to what we discussed in agricultural location theory in the context of agricultural geography, when we come to talk about industrial geography, we need to talk about Weber's industrial location theory. Weber is a German economist. You may have heard the name of Max Weber. Max Weber is a very famous sociologist, German sociologist, and Max Weber had a little brother, Alfred Weber. And this Alfred Weber was also a famous person, but he was famous among economists and economic geographers. And in the early 20th century, he wrote a book. It's called Industrial Location Theory. In that book, he systematically discussed factors that have impact on the location of industry, and he believed that one of the important principles that you need to hold on to is that whenever you are looking for the best location of an industry, you make sure that you need to find a site where you have least the cost, the minimum cost. That's why his theory is also called the least cost principle. Now let's break down the two parts to discuss the Weber's industrial location theory. First, how do we find the least transport cost location? We'll try to find a location for a industry where the shipping cost is a minimum. Now let's imagine that we have a factory. This factory uses two localized material, M1 and M2. Also ship the final product to the market at sea. Now this is formed a famous location triangle. Now where this factory should be in order to use material 1 and material 2 to make the final product and ship the final product to market at sea. Now Weber talked about economic equilibrium. Now economic equilibrium in this context can be interpreted like this. Imagine that the cost for material 1 is very expensive. Where do you think that this factory is more likely to be located? So if the cost of material 1 is extremely expensive, this factory is more likely to be somewhere closer to the corner to the material 1. And if the cost of material 2 is very high, that may make the factory move toward this corner. Or if the cost of shipping the final product is very expensive, that would try to pull this factory toward this corner. So it looks like that each corner have some kind of pull to this factory and to its own corner. So depending upon how expensive each of the cars is. So imagine that these different forces pull this location to pull the factory to their own corner, and at some point, as forces from different directions will balance out, will cancel out. Then eventually this factory will stop somewhere. And where this factory stopped is claimed to be the equilibrium location of the factory by Weber. So Weber believed that if this triangle is not too skewed, not too flat, he believed that this equilibrium location should be somewhere within this triangle, not outside. In addition, he believed that at this equilibrium location, the total shipping cost is minimal. So this is the concept of least shipping cost location. The issue is that in reality, how you go about looking for this actual least shipping cost location. So he used a physics device called Verignan frame. This is a picture show a Verignan frame. This is a device that used in teaching physics class. They try to illustrate how forces from different directions can balance. So Weber to create a device similar to the Verignan frame. If this is the original location triangle, you can you cut pieces of cardboard, then make that the same shape as original location triangle. Then you hang 3 weight over each corner. The weight are proportional to the weight of each of material 1, material 2, and final product. And then the other end of the weight is tied together like this. Then you let the weight go and to see where this knot will stop. And obviously, each weight will try to pull the knot to the own corner. Eventually, the weight from different corner will balance, and the knot will stop somewhere. And that's how we use this Verignan frame to find out how forces from different directions can balance. So that's exactly how Weber proposed to find out where is the least shipping cost location. So this is during the time of Weber, he figured out this is one way to do that. But nowadays, people already figure out how to use mathematical programming to solve the problem. But this is the initial contribution from Weber is here to use these simple techniques to find out where is the least shipping cost location. Okay, now we find out the least shipping cost location. Now Weber makes some adjustment to the least transport cost location. Let's say that we already find we have this location triangle, and the point P is the least shipping cost location. Now, if we have a location outside the location triangle where you have very cheap labor. Now, if you move this factory away from the location P to location L, what would happen to the total shipping cost? The total shipping cost will go up because we already said that the point P is the least transport cost location. So if you move away from it, the total shipping cost will go up. However, if the cost savings from cheaper labor can overcompensate for actual shipping costs, that the movement from location P to location L will be justified. So this is the idea from Alfred Weber during the early 20th century. Then come to mid-20th century, 1960s, when between the U.S. and Mexico, there's a Maquiladora project where the U.S. allowed the U.S. manufacturing to locate it in Mexico to take advantage of cheap labor there, eventually ship the product back into the U.S. market, you can really see this phenomenon basically has been discussed by Alfred Weber during the 20th century. So this kind of phenomena, cheap labor become a very important factor to attract traditional manufacturing away from developed countries. This has become common knowledge today, but during the 20th century, Weber already discussed this issue theoretically in his book. Okay. And we have seen this map before. This map illustrates how the cheap labor in the South helped attract many automakers to set up auto parts facilities in the U.S. South. Another factor that can also cause adjustment to the least cost location is the concept of agglomeration economies. Previously, we already discussed what is agglomeration economies. That is the benefit, the cheaper costs that are generated when companies come together located in the same location. Let's say that now we have factories. Three factories, they already have their own least shipping cost location at P1, P2, and P3. Now, what happened to the total shipping cost to the three factories if they move away from P1, P2, and P3 into the little region A? The total shipping cost will go up for all three factories because P1, P2, P3 are already the minimal shipping cost location. So if you move away from them, the total shipping cost will increase for all three facilities. But if the three factories move together closer to each other, they can enjoy agglomeration economies. Especially if this A is a big city, they can enjoy a lot of agglomeration economies by using the facilities, utilities, the labor force that are already there in the city. So they can enjoy the agglomeration economies. Again, so if the benefit from the agglomeration economies can overcompensate for the actual shipping costs for three industries, and that movement into the small region will be justified. So agglomeration economies has been realized by economists and economic geographers today as one of the most important factors that can explain the urban phenomena, especially the phenomena of big cities. But again, this simple principle has been discovered by Weber in the early 20th century. So all this can illustrate the contribution from Weber. Of course, just like agricultural location theory, the industrial location theory, since Weber has been updated, have been developed, have become more sophisticated, use a lot of sophisticated mathematics and statistics, but still we cannot deny the original contribution from his early founder, Alfred Weber. Well, this is the end of this topic. Now we have this term and a concept from the end of a chapter of the textbook. Hope you can check them out to prepare for the next time. All right, thank you very much. I'll see you next time. Goodbye.